Good morning.
Good morning. Hi, Brian. Hi, Vandana.
Hi,
Good to see you
Aviram. How
here.
are you?
I'm great. Great to see you both. Now it's 7 a.m. It's the best way to wake up. So thank you.
I understand. You're based in Israel, I assume.
Yeah, I'm based out of Israel, and yeah, very happy to be here. And I would like to share with our audience great insights about open source security tools. So thank you for the opportunity.
I think it's a great topic. You're kicking off with our keynote. Open source security is a big deal, specifically if you look at the whole supply chain. So let's, without further ado, let's bring up your slides like we do here, and I would say, hey, the stage is yours.
Thank you very much, Brian. So hi everyone. Today in our session, we'll talk about 5 open source security tools that every developer should know about. My name is Aviram Shmueli. I'm a co-founder and chief research and innovation at JIT. I live and breathe security for the last 25 years. I had the privilege to play on the attacker side, looking for vulnerabilities and exploitation, which is which is great, and also on defender side, which also was very important and proved to be valuable wherever I was. So I enjoyed both parts, the attacker side and the defender side, and this is my passion, doing working in the security industry. At JIT is a product security orchestration platform for dev organizations, for developers, DevOps, and DevSecOps people. At JIT, we leverage open source security tools and also commercial tools and provide them as one unified platform. This led us at JIT to explore many security tools. Many of them are open source. We created automated benchmarking, and we were able to understand quite easily which open source is better and which one, for example, should be used also by other people. So these are the insights that I would like to share with you in this talk. So, open source security tooling has seen a massive growth and maturity in the last few decades. Today, they are very, very good, high quality open source security tools, and some of them provide a good competition to commercial tools, and sometimes they even surpass the functionality of some of them. There are also active communities behind these open source tools, which benefit with the tools. For example, the active community supports the the bug fixing. They are made very very rapidly whenever there are active communities, and they also leverage the crowd wisdom, which is great. Also, many open source security tools are provide a good experience for developers. This is why developers would like to use them. So in short, open source security tooling could be great. The question is how we select them, because there are many of them. So in this talk, we're going to talk about few aspects of selection of security tools, open source security tools. First, we will decide upon the 5 categories of tools that we would like to consider. There are more than 5, but we'll focus on 5. Then we'll talk about how to evaluate an open source security tool. I will share with you our recommendation according to the benchmarking that we did. And we'll talk also about how we can leverage these tools to create adoption in the organization. And there will be also a few other stuff that we will talk about. So first, we would like to see which categories of product security we would like to focus on. So there is code scanning that you're all familiar with. There's also the category of dependency check, what is called in the industry SCA. There's also another category which is related to code scanning, but it's focused on infrastructure as code scanning. There is also web app scanning and API scanning. container image scanning. We can also do cloud scanning with open source security tools, Kubernetes scanning, whether it's static or in runtime. And there are another category which is related to the configuration of your SCM, for example, GitHub. There is category which is related to how do we look for misconfiguration in the components which compose our CI/CD pipeline, for example, GitHub. So there's plenty of security offering which is related to these categories, and there are also more categories than that. But I would like to focus on 5. Code scanning, dependency checks, which is the SCA, infrastructure as code scanning, container scanning, and web app scanning. And throughout this talk, we will delve into these categories and we will see which tools we decided to work with and why. So the question now is, how are we going to evaluate an open source security tool? First, we need to make sure that it works, right? This is the first and foremost, most basic consideration. The tool should work. It should provide good detection, low false positive rate, and high true positive rate. These tools also need to provide a dev experience. If we would like to leverage these tools by our engineering, we need to make sure that they are friendly to engineers. So they should provide a good user experience for developers. They need to be mature. If you would like to use a security tool in production, we need to make sure that there is a large community behind it. Bugs are gonna be fixed. There are a lot of contributors which are involved in this tool. People are using it. You can check it, for example, by the number of stars. But basically, this should be a tool that someone is working on. And customizability, which means that the tool needs to provide a way to get it customed. For example, adding rules, extending its policies, and so forth. So this is what we talked about: result quality related to false positives, false negative, true positive. Developer experience, it should be fast. It should run everywhere in the terminal, in the IDE, inside the CI. Developers need to be able to run the tool by themselves. And the maturity aspect, the tool should be popular. It should be there should be enough contributor to this tool. Bugs should be fixed quickly. The licensing model should permit our usage. And customizability related to the way the capability to extend tool with our own rules and to customize it to our own needs. Okay, so let's start with code scanning. So the mission of code scanning is to identify vulnerabilities in the code as soon as possible, meaning doing a shift left as much as we can, finding these code vulnerabilities in the IDE or in the CI. And many times these tools, they cover the OWASP top 10 and another list of risks. Also, these tools can discover secrets. Secrets include credentials, keys, and so forth. This subdomain, the secret detection, is also part of the code scanners. So basically, we would like to run a code scanner on our code to look for issues as early as possible in the software development lifecycle, and hopefully to remediate them. There are plenty of tools in the open source community today that provide code scanning. Many of them, by the way, they are focused on specific language. For example, Bandit is a tool which is focused on Python. Robocop and Brakeman are focused on Ruby. And AWS Git Security focused on secret detection, and Gitleaks focused on secret detection. We decided to go with semgrep. The reason is that semgrep detection is working amazingly. It's a very reliable tool with a high true positive rate and low false positive rate. It has a library of more than 2,000 rules ported from other open source solutions like Gitleaks, FindSecBugs, GoSec, and others. And it supports over 30 languages. That means that if you would like, for example, to initiate code scanning for your project, most probably that it will be supported by semgrep. Moreover, you'll be able to import the rules from semgrep libraries and to use these rules in your project. So there is a wide range of capabilities, detection capabilities that are provided by semgrep. For example, if you would like to leverage the semgrep rules which are related to Gitleaks, you can just run semgrep with p/ and Gitleaks, and your execution, this current execution of semgrep, will apply the Gitleaks rule. So it's very extensive. There's a lot of more than 2,000 security detection rules which are provided by semgrep. Also, semgrep can run everywhere. It can run in the CLI and CI/CD as a Docker in the IDE, and it's very fast. So it's very, very dev friendly, and really, you can run semgrep on your terminal in less than 1 minute. Very easy to use, and it's customized. It's you can write your own rules. You can extend semgrep with your own rule, and it's very easy. And this is what we did, for example, at JIT. We developed our customized rules, and we're using this rule. Very easy and straightforward. Also, semgrep is a very popular rule, a very popular security tool. You can see in GitHub according to the number of stars and number of contributors. There's a huge community that contributes to semgrep, and yeah, it's very popular. So we decided to go with semgrep to enjoy the library of rules, its extensibility, and its massive popularity. Okay, let's move to the next category, which is dependency check, what is called SCA. So the purpose with SCA is to detect open source components, open source library in packages with publicly disclosed vulnerabilities, which means that vulnerabilities which are known and were published. In this case, also we have plenty of tools that are open source. For example, OSV-Scanner, which is a tool supported by Google. NPM Audit, which is focused on JavaScript with NPM package. Dependency Check, which is a SCA solution for Java, and so forth. We decided to go with OSV-Scanner. OSV-Scanner provides a very good detection because it's based on OSV-Dev database, which is maintained by Google, and it actually aggregates curated sources of vulnerabilities. It also supports 13 languages, which means that if you would like to do an SCA for your project and you use more than one language, then you can use that with OSV-Scanner, which will provide coverage to the languages that you use, and you will not need to work with more than one tool. Also, OSV-Scanner can run locally in the terminal, in the IDE, and the CI. In that term, it's very friendly to use by developers. Again, it can also be invoked very easily by developers, and for that, it is very friendly. OSV-Scanner is able to scan different log files for different languages and package managers, and it provides customability options. For example, you can do all sorts of configuration. For example, recursive scanning if your repo has subdirectories, or you can also ignore some subdirectories. So it's very flexible, and it's gaining a lot of popularity in the recent year. And we expect that it will grow even better and provide more remediation capabilities according to what the maintainers say. And having the remediation capabilities is very powerful in SCA, because not only that we would like to detect packages with known vulnerability, we would also like to to have a way to fix or to upgrade these packages, and the tool provides that today to some extent, and will enhance this capability according to what the maintainers say. So that's great. So this is how the OSV-Scanner output looks like, and you can see that, for example, it detected XSS in a Django library 2.1.5, and it also provides information that it was introduced in 2.0.0 and it's fixed from this version. And this is the beginning of providing, advice or guidelines about what you should do. And in the future, we also believe that they will do the remediation by themselves. Okay, let's move on to the infrastructure as code scanning. And the idea here is to detect security misconfigurations in infrastructure as code before they reach the cloud. This is the best way to catch cloud-related misconfiguration, because in a progressive organization where they start with infrastructure as code, this would be the best way to catch a misconfiguration or security issues and to fix them while they are at the code level and before they are deployed to production. There are many vulnerabilities that can be associated with infrastructure as code, starting with missing encryption, for example, to S3 buckets, excessive access, many times lack of proper configuration of security group can result in excessive access. For example, being able to connect to your machine from everywhere to certain port or to all ports. So these are some well-known misconfigurations related to excessive access, the fact that there is no logging, and others. So there is a bunch of vulnerabilities which are related with when we write infrastructure as code, and these tools, their purpose is to catch these vulnerabilities and misconfiguration. In that case, there are also, you see, there are many security tools which are great, that look for infrastructure as code misconfigurations. Checkov by Breachthrough, KICS by Checkmark, TFX by Aqua, Terrascan by Tenable, and others. And this is great. Whenever we have a community which backs the open source, it gives it point, because it means that someone is maintaining this open source, most probably. And yeah, in general, these all tools do a great job. However, we decided to go with KICS, and the reason we did that, it's because KICS provides out of the box more than 2,000 queries, and each query looks for a certain misconfiguration or vulnerability in infrastructure as code, which is great. All of that come out of the box. KICS also supports 18 frameworks, for example, Terraform, CloudFormation, Pulumi. All of that are supported out of the box by KICS. From the developer experience, KICS did something great, which is supporting about 200 of remediations, which means that for about 200 of their detection capabilities, they will also provide you a guideline how to fix this piece of code. This is very powerful because we believe that everyone should have the fix first mindset, not just about detection, but also about remediation. Because we want to remediate eventually, not just to get flagged about all detections, all vulnerabilities that we have, but also to find a way to fix them effectively. So KICS in that sense does a very good job while providing these 200 remediation recipes. Also, KICS, it can be invoked very easily. It can be executed in locally in the CI and through the IDE, and it can also be extended. The queries, by the way, are written in OPA using Rego language. And again, there is a growing popularity and number of community contributors, and including JIT, for example. So this is a sample of an output coming from KICS. So you can see here an EBS, Amazon Elastic Block Store, which has no encryption. You see, I marked it here. I made this comment to make sure that it's not encrypted when it is defined. And KICS will say, you know, I scanned this piece of code, and the EBS volume is not encrypted. This is a medium severity issue, and it will also provide a fix for that. So in this case, this is a simple example of how KICS does the analysis for Terraform code. Let's move on to container scanning. So the mission of container scanning is to detect vulnerabilities and configuration issues in container images. We compared 3 tools, Trivy, Claire, and Gripe, and we decided to go with Trivy. Not only Trivy provides a very good detection quality, it also supports container images, file system, Git repos, and other. It's very easy to use. It is fast. There is no setup or prerequisites required. And again, it can run everywhere. To run Trivy, you can run it using the extensibility through its modules. You can write, for example, your detection logic, and there are plugins that you can use to extend the CLI. Also, in terms of maturity, this is a very, very popular tool with a large community behind it. So let's see an example. Here I asked Trivy to scan a container image, WordPress, and we see a list of findings which are related to specific library, which is part of this image. The library is the libc bin, and these are the CVs which are related to this container image. Okay, the last category that we would like to discuss is the web app scanning. The mission of web app scanning is to detect vulnerabilities in web applications and API while they are running. DAST, the dynamic application security testing, is a very, very popular vertical in security, and it's also a well-known vertical, which means that it lasted. It was born decades ago. In this case, we benchmarked 4 tools: Zap, Nikto, Wapiti, and Arachne. We decided to go with Zap. Zap is a huge project. It has numerous features, and it can detect the OWASP top 10 very easily. it has more than 250 rules for detection. Some of them are passive rule and some are active rules. With active rules, ZAP is trying to generate attacks towards the web application that you would like to explore or to pen test. And also there is the other way around is the passive rules, which means that ZAP just examines the response and the request and tries to understand according to headers if there is some misconfiguration. So there are two different rule sets, and they are all supported by ZAP. ZAP can run also everywhere as a Docker from your terminal, or they also provide a desktop app, and you can also run it headlessly. So you can integrate it to your CI/CD pipeline. This is a very, very popular project, which is considered to be one of the GitHub top 10, top 1,000. So it's highly popular and usable. There's also a ZAP marketplace with about 100 of plugins that you can use. For example, you can write your own script to customize ZAP. There is a UI for ZAP. There is the active and passive scanning and many capabilities which are extensions to the core ZAP. It's a large project that his maintainer was working on it for many years so far, and the results are very good. It's very fascinating, to try ZAP on a vulnerable web application and to see how it detects SQL injection and other injection techniques. So this is an example of an output coming from ZAP. So in this case, ZAP detected the cross-site scripting, and it provides the details about it and how it provides an evidence and how it simulated the attack, and also other relevant pieces of information. Okay, so to sum it up, we examined, we were interested to cover 5 categories of open source security tools, and we decided to go with these 5 according to our testing. Semgrep for code scanning and secrets, OSV-Scanner for SCA, KICS for infrastructure as code scanning, Trivia for container scanning, and ZAP for web application scanning. Okay, so we understood which categories we would like to explore and which one are important to start with. We also evaluated this open source security tools, and I shared with you our recommendation. But now the question is, how are we going to leverage this tool if we are going to use them? So my recommendation is to keep your development team involved from day one. It's very important to keep them engaged and involved, because if you would like to implement security, which starts with the developers, they need to like the tools and appreciate what they are using. And I would also say that it's important to start small with a small scope. It's also important to start with a non-blocking mode. Otherwise, if there will be false positive, and false positive may occur, and it will be operating in a blocking mode, then it can create frustration, and developers will not want to use it. So I would recommend to start with a non-blocking mode, and this will be at least as a start until your developers will like it and gain some trust, and then you can switch to blocking mode. It's also important to get feedback from developers, make them heard, so they can share valuable feedback with you. This will enable you to tune the tool and its settings, and to expand the rollout for other assets in the future. It's also important to establish and track KPIs. For example, are my developers using the tool? Do they do remediation? Do they just ignore everything they see? So it's important to track these KPIs and to use them as before you make a decision to expand the rollout or to switch a tool. Okay, so is this it? This is all we need to take care about, just selecting the tool and harnessing our developers? So the answer is no. And this is because we have few other challenges. First, how are we going to scale the rollout of a tool? Let's say that we started with 3 repos that only one team is working on. How are we going to expand the rollout to 100 repos? Is it going to be easy? How am I going to configure that? What's going to be the impact on the entire development team? How am I going to achieve a consistent behavior across all tools? Let's say that I picked up these 5 security tools. Each of them has a different interface. Their output looks different. Their interface are different. Maybe they speak with a different terminology. We will need to create some kind of a normalization layer that will take their output and will create a unified interface. We also need to create a unified interface in terms of how to execute these tools. Some can be executed as a container, other has a user interface. How are we going to create the same consistent behavior with all tools, which are born different, and they are different? What are we going to do with upgrades? You know, the tools that I shared with you, they are very popular and they have a large community behind them. The maintainers take care about them. So there are constant upgrades and bug fixes. How are we going to manage all of that? You know, when working with 5 security tools, it may happen that you will need to do an upgrade for at least one every week or 2. So how are you going to manage that? Another aspect is how to differentiate the experience of all the backlog, all the vulnerabilities that are detected on our code base, which is the existing code base, and all the vulnerabilities which were discovered when scanning this code base, versus new vulnerabilities from the moment that you install the tool. We believe that there should be different experiences here, because your developers, which are now getting to work with a new tool, they don't want to deal with vulnerabilities detected on a 2 years old code base, which does not actually relate to what they currently do. Developers would like to work on to fix issues which are related to what they are doing right now. So if I'm writing a new piece of code, the best experience for me would be to get vulnerabilities which are related to what I'm doing right now, not to all vulnerabilities which exist in my code base for the last few years. So how do differentiate between these two experiences? Finding old vulnerabilities to new vulnerabilities. And also, we will need to measure the remediation guidance. Was it good or not? So even if we provide that out of the box, we need to understand, to measure whether our developers are satisfied with the remediation. Does it work? Or maybe it's not that accurate remediation. So this should be also measured and tracked. The measuring is very important part of having security tools, and especially open source security tools. It's very important. And for example, you can track your security detection rate, which means that how often a scan contains a security finding, the mean time to resolve, how much time it takes me to resolve a vulnerability from the moment I see it, and the exposure window. For how long findings remain open in my organization until they fixed. These metrics can teach us about how our team is doing in terms of security. Is my team improving during time? How bad in terms of security is my code is, and also another learnings. So it's important to also to measure these KPIs. Okay, so I hope it was interesting for you. If if you will try one of these open sources and maybe adopt it, I feel that I did my job. We at JIT, we appreciate open source security tools. They are part of our platform, and uh, and we believe that some of them are very popular and provide high quality, which is not less, which is not which is rival and provides a good competition to other commercial tools. So feel free to write to me at aviram@git.io or to send me a tweet or LinkedIn message, and I will be try to answer as soon as possible.
Thank you so much, Aviram. I mean, this was simply great. I mean, the overview of the amount of tools there are there and giving them 5 specific tools that people can use is, I think, a great start for any developer to just get started.